Okay, now we enter into simple point discontinuity. So here we are going to discuss those questions of continuity rather, where the questions will be defined over rational values of x or irrational values of x. All the questions which will involve rational values and irrational values, which means the functions will be defined not in terms of intervals, but this will be defined in terms of rational or irrational values of x. For instance, you may consider one function. Let us consider one function. Let's say fx is basically 1 when x belongs to rationals, minus 1 when x does not belongs to rationals. Okay, some can write this as irrationals also, which means x belongs to q complement. You can write this as q complement also. Q complement stands for irrationals. Now the thing is, this is the piecewise function. Now you can clearly see that the function is defined over either rational values of x or irrational values of x, and not in terms of interval. What you have seen so far, the functions were defined in terms of interval, right? X is lying in between 1 and 3, or let's say 0, it's more than 0 or less than 0, whatever it is. But here we don't have any specific interval. So what we'll do in this case, also this function is a very special function. This is known as Dirichlet's function. Those who don't know, this is known as Dirichlet's function. This is known as Dirichlet's function. This function is also periodic. Okay, just if you see the graph roughly, just see the graph roughly, you will understand. For instance, let's consider this graph. When you have rational numbers, let's say you consider 0. 0 is a rational number. If you consider 0, the function value is basically 1, because for rational it's 1. For rational this is 1. So when you consider the value of x to be 0, so the function value will come over here at 1. Okay, now let's say I consider the next number to be irrational number. So the moment you consider irrational, this will fall back to minus 1. So the function value will come to minus 1. Okay, we are not sure which irrational values we are taking, but definitely the moment you take the next irrational number, so this will come down to minus 1. Okay, for instance, you consider the next number to be rational number. Let's say the next number to be a rational number, the function value will go back to 1. The function value will go back to 1 over here. Likewise, you may consider any irrational value or any rational value. Okay, let's say the next number is basically irrational number. The moment you take the next irrational number, the function value will once again come down over here at minus 1. Okay, and likewise this process continues. This process will continue like this, something like this. You can say there will be many such points. This will continue like this. Okay, getting my point? This will continue like this. So you can see that this is also a periodic function. This is also a periodic function. You can consider this to be a periodic function. And this graph is repeating, but the period is not defined. There was one more function. If you remember, we have done this under function section. There is one more function which is known as the constant function. Constant function is also a function whose period is not defined, but still the function is said to be a periodic function. I hope you remember the graph of a constant function. Okay, a constant function is such a function. It's periodic also, but the periodicity is not defined. So far the functions, the periodic functions which you have seen, sin x and cos x and all these functions, you know the fundamental period. But constant function and the Dirichlet's function, you are seeing that the function is periodic function, but the function's period is not defined. The fundamental period is not defined. You don't know after which point the graph will repeat. Okay, so obviously you can clearly see that this graph is completely discontinuous graph. Okay, so definitely this graph is a discontinuous graph. So definitely this function is totally discontinuous in all real numbers. So this function is totally discontinuous. Okay, you may write down that this function is a periodic function also. If you want to write down the properties of this function, since it's a new function to you, so this is a periodic function also. Number one, it's a periodic function whose period is not defined. And number two, it's a discontinuous function. Okay, in fact discontinuous for all real values of x. Now suppose I consider one more function, a similar function. Okay, for instance, you consider the function fx, which is defined to be 1 when x belongs to q, okay, and 1 when x belongs to q complement. Okay, fx is 1 when x belongs to q and 1 when x belongs to q complement. So here you can see that both the values are same over here, right? Here both of these values, for rationals also it's 1 and for irrationals also it's 1. So if you just roughly see the graph of this function, for instance, you consider any rational number. Let's say I consider the 0. At 0, the function value is 1 because 0 is a rational number. So at rationals, this is defined as 1. So at 0, this is 1. So plot here we have the function value, let's say at 1. Okay. Now, the moment you consider the next irrational number, let's say, the moment you consider the next irrational number, this will still be 1. This will still be 1. The function value will be still over here. Any irrational number you are considering. So the next irrational number you are considering, the function value is still at 1. Now, the moment you take the next rational number, for instance, the function value is still at 1. Similarly, for next irrational number, the function value will be still at 1. So likewise, this will create such points over here. This will create such points, and ultimately, you will end up creating a line. Ultimately, you will end up creating a line like this. There will be infinitely many such points, and this will totally create a line which is y is equal to 1. Okay. And if this creates a line like this, so definitely you can clearly see that it's a constant function, and a constant function is always continuous. Definitely, a constant function is always continuous function. So in this case, this function is actually a continuous function. Here, the function is actually continuous. It's a continuous function. So the function is continuous for all real values of x. So definitely you can clearly see that when both these values are equal, the function clearly becomes continuous. Okay. So this is the main thing, and based on this concept only, there has been lots of questions from simple point discontinuity only, based on this concept that when both these two functions are equal, you can clearly see that the function becomes continuous. Okay. Now let's see some questions actually. So there was one question in JEE mains actually long time back though. So there was one question which says that fx is equal to x when x belongs to q or rational numbers and minus x when x belongs to q complement. Fine. So we have to find the number of points of continuity of this function. Number of points of continuity, also where this function is continuous. Mention those points also. Okay. A very simple question, simple function and simple question. What we do, what is the case actually, what is the method of solving this thing? You know that when these two are equal, the function will become continuous. So when x is equal to minus x, so the function will become continuous. So what we can do is we can solve for x. We can solve for x from here and simply find the points of continuity. So here this turns out to be 2x is equal to 0, which means x is equal to 0. So which means x is equal to 0 is one of the points of continuity. Both of these functions will be equal when x is equal to 0. So 0 is basically the point of continuity of this function. So there is exactly one point of continuity. Let's say, for instance, if they're asking for the number of points of continuity, so we can say that there is exactly one point of continuity. And what is that point? That point is x is equal to 0. Fine. So similarly, there was one more question which was asked in IIT. Once again, a very simple question. If you see the function was given like this, that x when x belongs to q complement and 1 minus x when x belongs to q. So it's x when x is irrationals and 1 minus x when x belongs to q, which means rationals. Once again, the similar question, what we do is we will simply equate these two functions. The question remains the same, the number of points of discontinuity, and find those points. Okay. So what we do to find the points of continuity, we simply equate these two. X is equal to 1 minus x, which means 2x is equal to 1, which means x is equal to half. So this x is equal to half is one of the point of continuity. It's the only point of continuity. When x is equal to half, you can see that these two functions are equal. And when they are equal, they are continuous. So definitely half is acting as the point of continuity. Okay. So now these are very simple questions. Let's increase the level of the questions to see what type of questions you can expect nowadays in the exam. Okay, so here we have the question. The function is given to be x square plus ax plus 1 when x belongs to q, and ax square plus 2x plus b when x belongs to q complement. So what we have to do is we have to find the values of a and b, provided that f is continuous at x is equal to 1 and e. So it's mentioned that f is already a continuous function. Now we have to find the values of a and b. Okay. So what I do? First of all, we know that this function is continuous when both of these branches are equal. When both of these branches are equal, then only you will find the function to be continuous. So what we do is we first equate these two, and this equals ax square plus 2x plus b. Okay. And f is already continuous. It's mentioned that f is already continuous at these two values, 1 and e. So if we just rewrite this equation over here as you just take x square common from here, so this becomes 1 minus a. Okay, and take x common from here, so this becomes a minus 2. Okay, and over here we have 1 minus b. This is equal to 0. So if this function is continuous at these 2 points, so definitely 1 and e will satisfy this equation, or rather we can say that 1 and e is basically the roots of this equation, isn't it? 1 and e are basically the roots of this equation. So what we can do is we can simply put the value of x is equal to 1, and then we can put the value of x is equal to e. From there we'll get two relations, and we are going to solve for a and b, because our ultimate target is to solve for a and b, right? So what we can do is we can simply put this over here and solve for a and b. We can do this thing, or there is one more procedure. We can use the BITSAT formula to simplify this thing, which means we can use the formula for sum of roots and product of the roots, right? Because we know the sum of roots, the formula, we know that 1 and e are basically the roots of these two equations. These are two roots of this equation. Okay, so either you replace the value of x by 1 and then by e and then solve for a and b. You will get two simultaneous equations, and then you have to solve for a and b from there itself by solving. Okay, or you may use the BITSAT formula to simplify, which means you can use the formula for sum of roots. The roots are known to us, right? The roots are known to us. So 1 plus c, the sum of roots is what? Minus b by a. Alpha plus beta, for instance, if a quadratic has alpha and beta, roots are given by alpha and beta. So alpha plus beta will be minus b by a, and alpha times beta is c by a. So sum of roots 1 plus e is given by minus b by a. Now minus b means this coefficient. So minus of a minus 2 by a, the coefficient of this, that is actually 1 minus a. Okay, and then we have the product of the roots, that is 1 times e, which is given by c by a. C by a means this is c actually, so 1 minus b divided by a means 1 minus a. And then we can solve for a and b from here. Okay, fine with this. So now simply solve for a and b and we are done. So I hope this much workings you all can do to solve for a and b. Let's see one more question. Okay, so here we have the question which says that the function is given as x square minus ax plus 3 when x belongs to q, and 2 minus x when x belongs to q complement. So if the function is continuous at exactly 2 points, find the possible values of a. First of all, we know that the function is continuous when these two branches are equal. So we first equate these two branches. So similarly, let's rearrange this thing. We can rewrite this as x square, and here we have minus x and minus ax. So what we can do is we can rewrite this as plus 1 minus ax, and here we have 3 minus 2, which is actually plus 1, is equal to 0. Now similarly, the function here, it says that the function is continuous at exactly 2 points, and these 2 points are two distinct points, and those 2 points will be satisfying this equation, which means this equation is having two distinct roots. This equation is having, this quadratic is actually having two distinct roots, and we know the condition for two distinct roots. When the discriminant is greater than 0, strictly greater than 0, we know that the quadratic is having distinct real roots. So from here we can actually have the idea that yes, if we use this condition, then we can get some condition in terms of a and we can solve for a from there, which means what I mean to say is if you just solve this thing, what is z? Discriminant b square minus 4ac, which means 1 minus a whole square b square minus 4 into a into c. A means 1 and c is also 1 in this case. Okay, and this thing is strictly greater than 0. So over here this turns out to be, just simplify this thing, so this turns out to be what? A square minus 2a plus 1 and minus 4 is greater than 0, and this ultimately turns out to be a square minus 2a minus 3 is greater than 0. Now if we factorize this thing, what we get from here? We can factorize this thing. You know how do we solve polynomial inequalities of this type? We factorize this and then we solve for the values of a by using wavy curve method. Okay, so let's linearly factorize this thing. So if you factorize this thing, so this turns out to be a plus 1 into a minus 3. Just basic linear factorization, a plus 1 times a minus 3, and this is greater than 0. Now what we can do is we can use the number line method to solve this thing. Okay, we can simply use the number line method, or what you call as the wavy curve method. Okay, so what are the turning points? Minus 1 and 3 over here. Although this is a very simple inequality, you can solve just by visualization itself. Okay, so here we have the region more than 3, it's positive, negative and positive. So you want the region where this is positive, so definitely this is the required region and this is the required region. So clearly over here a belongs to minus infinity to minus 1 open union 3 to infinity. Okay, now let's see what are the other possible ways the question can be asked. The same question can be asked. For instance, this would have been mentioned over here that fx is continuous at exactly 1 point. Then how will we solve it? Definitely for 1 point, this equation will have equal roots. Obviously yes. If the function is continuous at exactly 1 point, then definitely it's a quadratic equation and you need 1 point. So definitely the roots needs to be equal roots. Okay, and we know the condition for equal roots, d must be equal to 0. The discriminant must be equal to 0. Then only you will get equal roots. So clearly d must be equal to 0. So if d is equal to 0, which means discriminant, which means a plus this factorization only. We have already calculated d, right? What is d? D is this thing only, a plus 1 times a minus 3. This thing must be strictly equal to 0. So from here you will get two values of a will be minus 1 and a will be 3. So for these two values of a, you will see that the function is continuous at exactly 1 point. Or rather, more specifically, that these two values of a, for these two values of a, you will see that this quadratic equation is having exactly one root. Now suppose, for instance, if this would have been mentioned that fx is totally discontinuous. Fx is totally discontinuous. For instance, the question would have been in this manner that if fx is totally discontinuous, then find the possible values of a. Right? So when function is totally discontinuous, what happens? There are no roots, or rather the roots are imaginary. Right? If the function is totally discontinuous, then we can clearly say that the function is actually, this equation is actually having no real roots. All the roots are imaginary. So definitely the condition, we know that for imaginary roots, we know that d must be less than 0. And what is d? D is this only, a plus 1 into a minus 1. A minus 3 must be less than 0. And we have already calculated this thing on the number line. So which region we need now? We need this region now. Okay, where this product is negative. So our answer would have been a belongs to minus 1 to 3 open interval. Okay, so we have discussed three cases. What happens when the function is continuous at exactly 2 points? Second one we have discussed. What happens when the function is continuous at exactly 1 point? Then d will be equal to 0. And third case was what happens if the function is totally discontinuous. In that case, there will exist no real root. All the roots will be imaginary. So in that case, d will be less than 0. Clear with the question? So these are the possible three questions which you can get. Okay, so now we have this question where the function is given to be x square plus 1 when x belongs to q complement and tan x when x belongs to q. At how many x in this interval 0 to 4 pi the function continues? The question was asked in CMI 2016. So we have to find the number of points of continuity. That's all. So what we do is we first equate. We know that the function is continuous when both these branches are equal. So x square plus 1 is equal to tan x. So just we have to find the number of solution for this equation. The number of solution for x square plus 1 is equal to tan x. Or rather we can say that the places, you have to find those places where the graph of x square plus 1 will intersect the graph of tan x. Right? You know that when fx is equal to gx, let's say for instance, these are some standard questions which you can sometimes expect in the competitive exams, that when fx is equal to gx and you need to find the number of points, or let's say the number of solutions of this equation, fx is equal to gx. So the standard procedure is to see the number of points where these two graphs will intersect. The graph of fx and gx will intersect. So the places where they will intersect, you will find the solutions over there itself. So let's consider the graph of tan x over here in between this interval 0 to 4 pi. So here we have the graph of y is equal to tan x in this interval 0 to 4 pi. Okay. And it's a standard graph, so you must be knowing what is the graph of tan x. Now we draw the graph of y is equal to x square plus 1 and we see the points of intersection. It's a very simple graph, y is equal to x square plus 1, right? So I hope you know the transformations. First of all, y is equal to x square is a parabola. You all know the graph of y is equal to x square. This passes to the origin, something like this. This is the graph of y is equal to x square. This is the graph of y is equal to x square only. Y is equal to x square. Now you need the graph of y is equal to x square plus 1. So what will you do? You will shift this graph by 1 unit up. Okay, so this graph will simply get shifted by 1 unit. Something like this way. The spin graph will be the graph of y is equal to x square plus 1. Okay, so once you draw the graph over here, so something like this graph will now pass through 0, 1. So the graph will be something like this. This will pass to, let's say over here, this is actually 1, something like this. The graph will be something like this. Very roughly I'm drawing the graph. Something like this you will have. Okay, only this region. So clearly you can see that there are how many points of intersection? 1, 2, 3 and 4. So total there will be 4 points of intersection. So there will be total 4 solutions. So we are not interested at what values of x you are getting, since in the question they have only asked for that how many values of x are there for which this function is continuous. So you can clearly see that there are total 4 values of x for which the function is continuous. So answer will be 4 in this case, total 4 values of x. Now, for instance, there can be one more question where trig functions can be considered. Let's say, for instance, in the function itself, if I consider sin x when x belongs to q, okay, and cos x, let's say, when x belongs to q complement. For instance, they are asking for the number of points of continuity. Also find the points. We know that this function is continuous when sin x is equal to cos x, when these two branches are equal. Sin x is equal to cos x, which means tan x is equal to 1. And when tan x is 1, we can find the general solution. Tan pi by 4 is 1. But let's see the general solution. We know that tan x is 1, then x is equal to n pi plus pi by 4 for n belongs to integers. Okay. So as you keep on putting the values of n, you will keep on getting solutions, right? So total, there can be infinitely many solutions. So in terms of general solution, we have this is the answer. X is equal to n pi plus pi by 4. Now let's consider one subjective type question